This is X3, questions 9 and 10 related to principal component analysis. And the first question is about just finding the principal component. So the first step is to rewrite this as PDP inverse. So the standard eigendecomposition form. So we have the diagonal matrix in the middle already. So we only need to add the eigenvector matrices, which could be 0, 1, 0, 0, 0, 1, and 1, 0, 0. And its inverse is exactly the same thing because the inverse of identity is still identity. So now we have three different eigenvalues, and the eigenvector corresponding to the first eigenvalue is the first column, and similarly corresponding to the second vector is the second column, and same for the last one. So the next step, to find the first principal component, you find the largest eigenvalue. So 10 is the largest eigenvalue, and the corresponding eigenvector is 0, 0, 1. So that will be our principal component. So that's just 0, 0, 1. And the next question is asking about projected variance. So we want to use the projection formula that says we just do U transpose X or X transpose U, they're the same thing. If we want to do that, we want to make sure that U is a unit vector. If it's not, we should make it the unit vector. So let's check. If we have a vector, and if you divide this by the length, then you get a unit vector. So the length is just square root of everything squared, which if you compute it is actually 1. So this indeed is a unit vector. So we can do the U dot X thing. So it turns out it's very easy to compute U dot X1, which is just the dot product between this thing and 0, 1, 0. So it's 0 times 8 plus minus 2 times 1 plus 0 times 10. So it's minus 2. And the second one similarly is minus 3. So now the only thing left is to find the variance. We already have the projection, so next is the variance. And the variance is computed by this MLE formula, which is just dividing it by n. Sometimes I want to use the version with 1 over n minus 1, but here, just divide it by n. So basically it's half times minus 2 minus the average. The average of the two is 2.5 squared plus minus 3 minus 2.5 squared. So it's basically, you can compute this, it's just half times 0.5 squared plus 0.5 squared, which is, I think, 0.25. But you can verify the computation.